welcome to the Building Your Own DAO workshop hosted by Siraj from Polygon. Siraj, big welcome to you. Very excited. The workshops have been amazing so far. So we look forward to your workshop. And yeah, please just keep yourself muted. And if you've got any questions, just ping them in the chat, and Siraj will answer them along the way. And if there's any kind of other things you need regarding the hackathon, just send it in the chat and I'll answer them in the chat for you. Yeah, so Raj, big welcome, and over to you.
All right, perfect. Thank you so much, Jake. Okay, hi everybody, I'm Siraj Raval. I'm focused on developer education at Polygon. And today I'm going to give a talk on how to build your own DAO, which is a decentralized autonomous organization with Polygon. So to start, I'm going to share my screen and let's get started here. So we've got this thing called the Polygon Academy, and it's essentially just a Git book, but we took all of the best learning resources from across the web, put them into a sequential curriculum from extreme beginner all the way to like super advanced, like quadratic voting and, arbitrage bots and like super advanced stuff. And, if you're interested in learning about Polygon, that is one resource that if I could only pick one, I would point you to that one. But today what we want to do is we want to build a DAO, a decentralized autonomous organization. And this is a concept that I personally have been writing about for 7 years now. 7 years ago, I wrote this book, which was released by O'Reilly called Decentralized Application. Okay, not 7 years ago. This was 6 years ago for O'Reilly called Decentralized Applications. And, back in 2016, Bitcoin existed, Ethereum existed, but there weren't this, there wasn't this ecosystem of decentralized apps that we have today. And my goal in writing this book was to try to invoke it by getting people to build on Bitcoin and to build on Ethereum. And what happened was people did start building with these technologies. They did start building decentralized Uber. They did start building decentralized Airbnb. One great example of a decentralized Uber was called Lazuz. It was a crypto alternative to Uber. And this was back in 2015. Lazuz was trying to create this rider-driver owned decentralized ride-sharing app. And they were based out of Israel. And they were building with all the right technologies. They were building with Ethereum. They were storing their data on something called the Interplanetary File System, which was decentralized file storage. They were, they were creating equity. They had a DAO where all the drivers got some equity in the network, which is the defining feature from Uber, where the drivers are contractors. They are not owners. So this was a very Web3 idea. And I don't think many people know about this, but this happened back in 2015. And whatever happened to Lazuz? Like if we go to Lazuz today, they started in 2014. They had all this money and all this funding, and now the page isn't working. So what happened there, right? It's not just Lazuz. Every idea, decentralized social networking for Facebook. What was there? There was something called Diaspora. And Diaspora, many people don't know, was a decentralized version of, Facebook or a decentralized social network. And of all the people to invest in Diaspora, there's three key philosophies: decentralization, freedom, and privacy. Mark Zuckerberg actually invested in this, weirdly enough. And I don't think many people know about that either. But what happened with Diaspora? This was around the same time. It turns out Diaspora died out too. And the founder, unfortunately, committed suicide because it did so badly. So what I'm trying to show you guys here is a pattern of failure when it comes to building scalable decentralized applications that has been going on since 2014. And all of this really was centered around not Bitcoin, because Bitcoin is great for payments. But that's what Bitcoin does really well. Payments, that's what that does. It was really centered around Ethereum. And Ethereum is a blockchain that is a Swiss Army knife. It doesn't just do payments. It allows developers to build not just decentralized payments, but decentralized social networking, decentralized ride sharing, decentralized house sharing, decentralized just everything, messaging, peer-to-peer, everything, right? But the problem was none of these things could scale. that was the killer of all of these things. Every time that one of these apps started, once they got to a certain scale, and that means over, a certain number of users, maybe like 100,000 users, gas fees would get real crazy. And we can see this, for example, today. If we go to, say, OpenSea, if we go to OpenSea, which is the world's largest or most popular place to mint your own NFT and sell them on a marketplace, we go to OpenSea and we try to mint our own NFT. It's going to connect to our MetaMask wallet, which is our gateway into Web3. It's going to say, okay, here's your account on, whatever it is. We're going to mint an NFT. It's on Polygon. We can also say Ethereum. And we're going to take a screenshot and we're going to put it on. So this is just a JPEG. We're going to say, here's our demo NFT. And then we're going to say, we want to mint this on Ethereum. Okay. And what OpenSea as a service does is it takes on the gas fee of minting this on Ethereum for us. But it's only going to do that for one. See, no gas cost for you. They're going to take on that gas cost because whenever an item is sold, they get a percentage cut. So that's their business model. They'll let us mint it for free, but then once we sell it, they're going to take a cut. And this works really well for them. But the problem is that if I want to mint more than one, you can see that this text field is uneditable because it costs a lot of money for gas fees on Ethereum still to this day. This was the same problem with Lazooz. This was the same problem with Diaspora. This was the same problem with everything, gas fees. When you get to the scale of Facebook with 1 billion+ users and every single interaction, whether it's a share, a like, a tweet, is happening on a blockchain, that is very expensive. It's very expensive and it's not scalable. But if you notice here, OpenSea allows you to mint this on something else called Polygon, which is a high-speed gas-free blockchain that works with Ethereum. And we're going to talk more about this in a second. But if we click on Polygon, then all of a sudden we can mint not just one, we can mint 100,000 NFTs. And we can do that instantly after we're, prove that we're real. And here's the bus, verify. And now we have minted instantly 100,000 NFTs on Polygon's blockchain. And you might be asking, well, why would I want to mint on Polygon? All I care about is Ethereum because that's the main blockchain and that's what everyone cares about. And that's where the Bored Ape Yacht Club and all these super expensive NFTs are. And that's what I'm going to explain to you today is why you would want to use Polygon, why I work at Polygon, and what the point of Polygon is. So like I said, the main crux of Ethereum has been the high cost of gas fees. That is what I have been trying to solve, and the community in general we are all trying to solve that. And around 2016, around 2017, a team from India came out and they said, we're going to build a sidekick to Ethereum. We're going to build a separate blockchain. And we're going to call this blockchain Polygon Proof of Stake. And this is an existing blockchain. And with this blockchain, what we're going to allow you to do is you can use every single tool that you would normally use with Ethereum. Solidity, Truffle, Ganache, all that tool set, which we're going to talk about. You can just build an Ethereum dApp, exactly how you would for Ethereum. But instead of deploying it to Ethereum, we want you to deploy it to our Polygon blockchain, which is an EVM, Ethereum Virtual Machine compatible blockchain. It's essentially a fork of Ethereum. And what Polygon's blockchain is going to do is it's going to, once you deploy your app to it, it's going to send all that data to Ethereum. So even though you've deployed it to Polygon, your app also lives on Ethereum. But what you get by deploying it to Polygon is not having to pay gas fees. How is this possible? How is this possible? So if we go to the Polygon docs, which are great, but can always be improved, we can see that we have a lot of resources here for developers on how to learn about Polygon. What are the basics? What does it look like? What's a validator? What's the proof of stake chain? All this stuff. So if we go to the architecture, we'll see this image here. And the green blocks are the Ethereum blockchain. The blue blocks are the Polygon blockchain, which we deploy to directly as developers. And these three icons of people are the validators on the Polygon network. So Polygon, unlike Ethereum and unlike Bitcoin, does not use proof of work. So the way the network's secured, is not by solving random math problems and just having as much computing power as possible. It's run by proof of stake. And if we want to see how that works, we can go directly to the web wallet interface to the Polygon blockchain, which is found at wallet.polygon.technology. And when we go to this wallet, we can see that we want to perhaps earn a return on our Polygon. So we can become a delegator by giving one of these validators our Polygon tokens. What these validators do is, instead of solving random mathematical problems, the more tokens they have, the more of a weight that their vote has. Every X interval, they will vote, or their computers will vote on which transactions are valid and which are not. And this is 99% more energy efficient than proof of work. And it's also a lot faster than proof of work by orders of magnitude. So the reason that Polygon's blockchain is able to have gas-free or very, very cheap transactions as opposed to Ethereum is this mechanism, this consensus mechanism, which is proof of stake. Because proof of work requires a lot of energy, right? If you've ever heard of a Bitcoin miner, you know, these things are as loud as World War II air horns. They're like really loud. And, you know, Bitmain has this thing called an Antminer S19J Pro, which is, you know, one of the most powerful miners out there. But this thing costs, you know, $15,000. I mean, this right this second, this costs $6,000, but it fluctuates with the price. But very, very heavy machinery. This is the reason why, you know, Bitcoin is very expensive to mint. It's not just expensive, it's impossible actually to have a Turing complete full stack dApp on there. But, you know, this is why Ethereum is very expensive, because there are machines like this that require a lot of energy. And so time is money, and money is energy, and energy is gas. So the less energy we have to use, the cheaper it is for us as users. So that, all that is to say that Polygon is a lot cheaper for users, and it is a lot faster, and it is the way to go if you want to scale your Ethereum dApp. And that's why I work at Polygon today, because it's not just because I like the color purple. It's because I have been trying to invoke developers to build scalable decentralized applications for 6 years now. And this is the way to do it today. I see hope in Polygon, because Polygon isn't just a you know, one-stop solution. There's many different solutions. As you can see, there's 9 different products. Polygon must be like the AWS of Web3. So we can go and talk about all these, but, you know, a lot of this is for a different talk. Like, for example, you know, Polygon Zero is the world's most performant ZK-L2, which uses Plonky 2. So all that is a lot of jargon, and we're not going to talk about this, but these are all scaling solutions for Ethereum. That's all that is, scaling solutions for Ethereum. But as developers, all we have to care about right this second is this one product called Polygon Proof of Stake, the existing in production blockchain. And that is what today we're going to use to build our decentralized autonomous organization. So that's all of a background on how we're going to do this. And now we're going to get to building. Let me quickly see if there are any questions here. Satyam asks, what about the security regarding proof of stake? And how do validators make decisions on voting yes or no for a transaction? 2 great questions. Let me start with the first one. So in terms of security regarding proof of stake, so there are many proof of work blockchains that have been hacked before, including Ethereum. Ethereum is a proof of work blockchain today. It still hasn't switched to proof of stake. The plan, Vitalik most recently said, I think a week ago, was the merge, the switch to proof of stake is going to occur in August. So we have 2 months. Who knows? They've been delaying it for years. So we don't know when it's going to happen, but hopefully it happens in August. And why haven't they switched? Primarily because of the security concerns around proof of stake. But, you know, when it comes to security, I think it's really a toss-up, because so many different cryptocurrencies have gone down. Solana has gone down, you know, how many times because of proof of history. You know, there was USD, or what was that big, the Terra thing that went down, and it was using proof of stake. And, you know, there's proof of work blockchains like Ethereum itself, what that went down with the DAO hack. I don't know how much money was lost in the DAO hack, but it was $60 million. And this happened on a proof of work blockchain. So, is there a one-stop solution to security? No, it is an ongoing cat and mouse battle. The better the security gets, the better the hackers are going to get. And it's just a back and forth. But what do I think about security and all? It depends on just many things, not just the proof of stake mechanism. How secure is the smart contract language, Solidity versus Viper versus Rust for Solana, and what bugs and exploits can people find, and how easy is it to socially engineer people to send you your funds? And so there's a whole stack of concerns. But overall, I think that if I were to pick, what's better, I would choose proof of stake because it's just more energy efficient and it actually scales for full stack, full Turing complete decentralized applications. The next question was, how do validators make decisions on voting a yes or no for a transaction? Now, this is actually a much more complicated answer than I could find on the internet. So what I did was I went and I made a little gist on GitHub that describes how proof of stake works, because I couldn't find one. And I call it rollup.js. I'm going to share it in the chat here. So this is called rollup.js. And what rollup.js does is it is a 81-line JavaScript example of what's called a zero-knowledge rollup. What it describes is how Polygon takes all of these transactions, thousands of transactions, and essentially does data compression. It does data compression. It compresses all of those transactions into what's called a Merkle tree. And it takes that Merkle tree, which is a very efficient way of storing many transactions, and it sends the root node, the parent node, which is a single ID, to the Ethereum blockchain. And in doing so, it rolls up, that's the word roll up, all those transactions into a single ID, and it does it with giving zero knowledge to the Ethereum blockchain of all the participants and their identities and what they actually are transacting with. It does it without giving it any knowledge of what those transactions are. And Ethereum will say, oh, okay, I don't have any knowledge of who these people are, and you didn't give me all the transactions, but I guess that I should believe you. And how should they believe you? Well, what happens is this generates a proof, a mathematical proof that all those transactions are valid. And this single JavaScript file will describe how the Merkle tree is constructed and how that data is compressed. And all that compression makes it easy for validators in the network to be able to say, this is valid and this isn't. So in short, to answer your question, how are the validators able to vote on whether or not transactions are valid? The answer is Merkle proofs, the mathematical proofs that say these are valid or not. And Merkle proofs are essentially Polygon's big investment. All of these are essentially math proofs. Maiden is a ZK rollup. Hermes is a ZK rollup. Zero is a ZK rollup. Nightfall is a ZK rollup. All of these are different variations of this 80-line of JavaScript file that I've shared with you. And these all generate a single equation. They generate a single equation of what's called a proof. And very briefly, this is the Fibonacci sequence, right? Where we can represent it as this visual diagram of you just take, to get any value at any index, you just take the previous two indexes, you add them together, and that's going to be the next value, right? So if we want to see what the value at B5 is, we just add the value of B4 or the two previous ones, 3 and 5. So, 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, and it goes on for infinity. One other way of representing this is using this equation right here. And this is a very basic equation that says A equals B and B equals A plus B. Another way of representing this is with a polynomial. So this is polynomial format. And this is a proof of the Fibonacci sequence. And so why am I showing you this? Because this is an example of a math equation, a proof that is generated from many transactions. So the Fibonacci sequence is an infinite sequence of numbers where the previous two numbers are added together to get the value at any given index. in this way, zero knowledge rollups generate something like this, which the validators or the Ethereum blockchain can plug and play a few numbers in. Well, and it can plug and play a few numbers in, like, how do I know that this proof represents all those thousands of transactions? Well, let me guess and check a few of them and see if the output is what I expect it to be. And if it is, I'm going to assume that everything is like that. That's how the validators decide on the validity of the network. That's how Ethereum decides on the validity of all those transactions, is through the different methodologies of constructing these math equations, which are called zero knowledge proofs. Okay, so that's that. Now we're going to get into the building a decentralized autonomous organization. So how do we do this? Well, what I like to do is I like to start real simple. So I'm going to share this with you guys, which is a GitHub repository by Party Like It's 1998. And this is really the most simple decentralized autonomous organization, DAO, that I found on the web. So I'd like you to go to this link, download this code. We're going to download it together and take a look at this. So here's the idea. It's called Simple DAO, and we're going to build it today. What Simple DAO does is it allows users, whoever joins the DAO, to vote. And what do we vote on? It's a simple yes or no. The vote does a simple thing. It just buys a cupcake or not. And that's how that works. We have two smart contracts. We have one smart contract that represents a digital vending machine that will dispense digital cupcakes. That's all that does. And these digital cupcakes are represented by integers, either 1 or 0. 1 is a digital cupcake, 0 is a different type. Then we have our DAO, and our DAO is represented by a different smart contract. Both of these are Solidity files, .sol. See, we have digital vending machine.sol, and then we have simple DAO.sol. Digital vending machine.sol is just a digital vending machine that nobody owns, and it lives on the Ethereum blockchain or the Polygon blockchain. And then we have simple DAO.sol, and that is our DAO. And that is how we as users, if we want to join the DAO, if we want to interact with it, if we want to vote, we have to send a transaction to that DAO. That DAO will hold all of the money from all of us together in a publicly verifiable way. Now, do we have to do it this way? No, not necessarily, but we're going to do it this way, and I'll tell you why in a second. Once we all vote on whether or not to buy a digital cupcake, then the DAO will execute, if the votes are in the majority favor, to buy the digital cupcake using Ether in this case, and then it's going to send a digital cupcake to the DAO, and then we all have shared ownership over that digital cupcake. And this is a very crude, simple example, but we can use that as an abstraction into, well, what else can we purchase together? Perhaps parcels of land in the Amazon rainforest. Perhaps we can save the earth using something like that. Maybe we can share ownership over, a ride sharing network or a social network, or, there's many different things, but let's start very simple with a digital vending machine. So, do we have to do it this way? No, we can go to stripe.com and one of us can create a Stripe account, and we can say, well, we want you to all send your money to the Stripe account, and then the Stripe account is going to go buy, some cupcake or whatever. Why don't we want to do that? What's the issue? What's the fundamental difference between, a bank account or an online, Stripe account and a DAO? The fundamental difference is that the DAO is publicly viewable. The funds are publicly viewable. Nobody can, take a little bit of funds, take a little bit of pie. You know how politicians do. Take a little bit of pie. Nobody knows. This is publicly viewable. So, and we all have mathematically verifiable shared ownership globally, transnationally. So this is really, this idea of a DAO is made for the internet village, which we are all in now. This borders idea is slowly dissolving as, so a kid in Kansas who's 12 has more in common with a kid in Singapore who's 12 than an adult in his own state. And that's because of the internet village and how we're all related and how meme subculture has taken over the internet. So let's get to this. So if we open this up, so you can see I was mining some Bitcoin here briefly. we're going to open up Simple DAO. There's Simple DAO. And we're going to open up that file locally. All righty. And what do we got here? We have some really ugly looking plain text, which we're going to highlight. Usually for Solidity, I just put on some JavaScript. So these are two smart contracts. We have digital vending machine, which is that autonomous, one way I like to think about smart contracts are they are essentially AIs. They're not owned by anybody. They are fully autonomous AIs that they don't require a human owner to exist because they live on the blockchain. So that's what the digital vending machine is. Usually a non-digital vending machine, someone would own it, right? But in this case, nobody owns it. So there are three different functions here that I want to talk about in the digital vending machine. Then we have our Simple DAO. And so what we're going to do is we're going to deploy this to the Polygon blockchain. And how do we do this? Well, one very easy way to do this without installing any local files is to use Remix. And Remix is the IDE for the internet for Ethereum. We have Simple DAO, and then we have the vending machine. Okay, so if we're going to call this file vendingmachine.sol. And if we go to this digital vending machine, let's compile this in the browser. And then we're going to do this a different way. Then I'm going to show you how to do this locally with local tools. So this is a digital vending machine, and this just signifies the version of Solidity we're at. And inside of the contract, we're going to declare two variables. Whoever mints the contract, which we're going to call the owner, and then we're going to have the number of cupcakes, which is represented by this cupcake balances. In the constructor, whenever someone creates this, which we're about to do, we're the message.sender, we're the owner, we're going to initialize this digital vending machine to have 100 cupcakes. That's what the constructor is for. And then in these two functions, these are the two key functions, refill and purchase. We're going to have two actions that can be triggered whenever money is sent. So refill is if we want to refill the vending machine. We can also have another we can also not have this. We don't have to refill it. We don't have to have an owner. We can remove the owner and we can remove the refill. But just for this case, for test purposes, we're going to have an owner. And then the purchase. This is the main function that is going to be triggered whenever someone buys something from the digital vending machine. So let's deploy this. So we have this here, this digital vending machine. This is not our DAO yet. This is just what we want to interact with. So we're going to deploy this to the blockchain. So first we're going to deploy it. First, we're going to compile it. It's going to say like, is everything good? And then we can deploy it because Solidity is a statically typed language, which requires compilation before execution. So we have to compile it first. And once we've compiled it, okay, it looks like it's compiled. Now we can run it. We can deploy it. So this is going to ask where we want to deploy it to. So I'm going to say we're going to deploy it to Ganache was running. We can run it on Ganache. So we're going to run it on our local blockchain called Ganache. So this Ganache, by the way, is a test blockchain that lets us just run our own local blockchain. So now we have a blockchain running, and it's an Ethereum blockchain. And here's the port that it's the server that it's at, localhost 8545. And if I want, we can just deploy it directly to my local provider here. And I click on deploy, boom, we've deployed it here to our custom little network here. And we can see these two, we can see the functions and we can interact with these functions directly in the browser, like cupcake balance, for example. Like if I click on that button, cupcake balance, first I need to get the address of wherever I deployed it. Then I'll paste that address in, and then it's going to say at that address, you have 100 cupcakes, right? If I want to refill, I'm going to say, well, I want to add 20 more cupcakes. I'll click refill. That worked. Now I'll look again at the balance, and now it's 120. So what we are doing here is we're interacting with a smart contract in the browser directly. And this is just like an easy way of doing that. So we've deployed this first smart contract to the browser. Now let's do our DAO, our decentralized autonomous organization. So we'll create one more. We'll create one more file here. DAO simple.sol. And we are going to do the same here by going back here to simple DAO. And before we compile this one, this one's a slightly bigger, 185 lines, but believe it or not, still one of the most simple DAO smart contracts, the most simple I've ever found, we could find. So in simple DAO, we're gonna have a few global variables. What's the vending machine address? Well, we have that vending machine address, right? We deployed it, and we have that vending machine address saved. So that's the address of the vending machine. We're gonna have users vote. So we have a vote start time and a vote end time on whether or not to buy a cupcake. What's the total balance in the DAO? What's the overall decision? And when has the vote ended? When the vote ended, which is a Boolean, which fires, when the vote ends, then the contract executes and buys a cupcake. So we have a voter and we have a proposal. The voter has a vote. The vote has a certain weight. This is actually unnecessary because it adds a little layer of complexity. Let's just say that all votes are weighted equally. There's different ways of structuring a DAO, by the way. You can have a DAO that's a dictatorship where one person has all the power. You wouldn't want that. You can have a DAO that is in all the different ways that there are governance methods, that's all the ways that you can structure a DAO. In this case, this is a direct democracy, you can say, where each vote has an equal vote. There's no delegation, although we could turn this into a representative democracy by delegating our vote to somebody, which is by default, but we're going to remove that too. And then we just have a voter who either has voted or not. And then they have a proposal. We don't have to have a string name for the proposal. We can just say, how many votes are there total? And then we have a chairperson, whoever set up the vote, and some error handlers. We construct all of that. We initialize all those variables whenever it started. What's the start time? What's the end time for the vote? How many users are there? What's the vending machine address? And then we have our helper functions, deposit ETH. Whenever we want to interact with this, we're going to deposit some money into it. We have give right to vote. That's for delegation, which we don't actually need. Then we have the actual voting function, yes or no. Do we want to vote or not? Then we have the count vote function, which is just an autonomous function which fires whenever the vote time has ended. And lastly, we have the withdraw function. If we've deposited some money and we don't want to participate in the DAO, we can very easily withdraw. Oh, and then there's one more, end vote, which just fires whenever the vote ends. And then just says, what's the total balance in the DAO? And are there any errors? Did everybody vote? So let's compile this. Simple DAO, or DAO simple. Compile. Okay, good. So now we have that there. Now we're going to do the same thing. We're going to deploy the same thing to our test blockchain. And we're going to deploy it. I have my contract here. So here's what. Because I needed to add these variables to the constructor. So how long is the vote going to be? Let's say it's 200 seconds. What are the proposals? I'm going to call it 0 and 1. Either you buy a cupcake or you don't. And what's the address of the vending machine? It's going to be like something like, I had it here somewhere. Let's put like a test number here, transact. And we're going to deploy this locally just because it's not been a good sport. So we're going to deploy it locally. In Sublime, we're going to deploy it. So we have simple DAO and so simple DAO. So, okay, I wanted to show you the other way of deploying, which is what we're going to do. We're going to use Truffle. Truffle is our test suite of smart contracts, and it allows us to deploy smart contracts to the browser. we have a lot of, remember, everything you use with Ethereum, you can use with Polygon. So what we're going to do is we're going to do truffle init, which allows us to create a local repository. We've started it. And now we're going to do truffle create contract, truffle create contract, and then the name of the contract, which is simple DAO. So well. And okay, so we create a contract called simple DAO. Oh, so we're going to create one. So I have some dependency issues. Let me see if I directly. Right, truffle compile. We're going to compile it. We're going to try a couple commands here. Oh, there we go. Okay, so we've compiled all of these smart contracts, including simple DAO, that were in this directory. So everything's been compiled to Ganache. So even though we use two different interfaces, one local, one on the IDE, both are connected to the same blockchain, which is Ganache. Now, Ganache right now is an Ethereum, is deployed to, it's like an Ethereum blockchain. But we can very easily just switch it so that it's deployed to Polygon. And right, so this allows us to choose which of the test Ethereum blockchains we want to deploy it to. But if we want to deploy it to Polygon, there's a tutorial right inside of the Truffle suite that essentially just allows us to unbox the Polygon tool set. And with Truffle Unbox, we can overwrite everything that we don't need. What this is doing, by the way, is it is switching the RPC, which is the test blockchain address, from London or Istanbul, whatever they're called, to the Polygon ones. And then we could just do truffle compile, and boom, we just did the same thing, except it's deployed to Polygon. It's the same code base. And that was super easy using the Polygon box. So yeah, so now we have simple DAO deployed to a blockchain. And yeah, so that is how you deploy a DAO on Polygon. Any questions? Truffle. So Truffle isn't just a collection of smart contracts. It's also a development environment for deploying smart contracts. It compiles smart contracts locally, and then it deploys them to the whatever blockchain you want, usually either Ethereum or Polygon. And then what actually executes the smart contract is the blockchain itself. So in terms of what runs the files, that's not happening on locally, that's happening on the blockchain. Drizzle is something that definitely doesn't get enough love. Like any sort of like visual design elements for Web3, we're very much lacking there. We need better, but yeah, this is something I can talk about next time, Drizzle. Well, thank you guys for being here. Appreciate it.
Siraj, thank you so much. If there's any more questions, we've got a couple more minutes. You can ping them in the chat. If not, we'll give it 30 seconds and then we'll call it. But yeah, there is a question there.
Transaction fees on the mainnet. Everything was testnet and free. Yes, everything was testnet and free. On the mainnet, it is like pennies, like less than pennies. On Polygon, it is pennies. So there is a fee in production. It's nowhere close, like 1% of gas fees on direct Ethereum. And if you use any of the direct Ethereum-based ERC20 tokens like Shiba Swap or whatever, you're going to have to pay huge amounts of gas fees to do anything. like staking. And I got burned a lot on this, so I know very much how that works. But if you go to, say, one of the Polygon dApps, and there's 19,000 of them now, like this one, Aave, it's got $15 billion worth of liquidity locked in. This is an open source protocol built with Polygon. You're going to see that the gas fees, whenever you want to stake here or do anything here, are going to be much lower than something like ShibaSwap. So if you want to see the difference, I would say go to Aave, and you can see something that is like legit, people trust, with $15 billion worth, and the gas fees are super, super cheap.
Okay. Any more questions out there? Siraj, thank you so much for that. I think we'll call it there then. That was a brilliant workshop. Please go follow Siraj on YouTube. We had a look, amazing YouTube channel, and a great Twitter account as well. So please, he's well worth the follow if you want to stay within the Polygon ecosystem, or just in general learn a whole lot more. Yeah, I think we'll call it there. Thank you so much. Enjoy the rest of your day. Cheers, everyone.